Good afternoon, everybody, and welcome to this webinar of the Moving to Maths 2.0 course. My name is Nadia Carrera, and I'm one of the moderators of this course, along with my colleagues Ben, Anastasia, and Irina, who is also here with us today. So you're now working on Module 5, which is the last module of the course, unfortunately. And but we really hope that you have been enjoying the course so far. And in this module, you have been working, or you will be working with the role of digital technologies in the classroom, in the math classroom, and we will also see how digital technologies could potentially change the way we currently approach teaching of maths. That's sometimes a bit complicated. And one way of doing this is through coding and robotics, and this is why we have here with us a great speaker. Her name is Tulia Ursic. Welcome, Tulia, and thank you very much for being here with us. To give you a bit of a background about Tulia, so she works as a math and science teacher in the lower secondary school in Lorenzo in Fumani, a little town near Verona. And she uses robotics and digital technologies inside the school curriculum. She collaborates with the Ministero dell'Istruzione dell'Università e della Ricerca. I hope the pronunciation is fine, Julia. So basically the Italian Ministry of Education, and she's a teacher training inside the Piano Nazionale Scuola Digitale, where she enhances learning and improving teaching methodologies with students. So Tulia also collaborates with the School of Robotics in Genoa, training students and teachers in the use of educational robotics inside the school curriculum. She's also a Google Certified Educator and Microsoft Innovative Education Expert. She has also been involved in several European projects related to the promotion of STEM subjects and in learning and teaching processes and the reduction of the gender gap. Over the last few years, Tulia has also been collaborated with us, with European Schoolnet, as a pilot teacher within the Ingenious and GoLab projects. And since 2013, she has been Italian ambassador for the Scientix project. She has also contributed to some MOOCs from European Schoolnet Academy, such as the How to Teach Computing and the ICT Administrator course, and also some other MOOCs, such as this one, the Moving to Maths 2.0 course from the Teacher Academy, and so the Teacher Academy by School Education Gateway. So she is definitely, I think, the best person to guide us through this topic today. So I hope the introduction is fine for you, Tulia. Otherwise, feel free to add or correct me or anything.
Yep. Okay. So, hello to everybody. I don't have to add anything more because Nayara told you about all my biography. Anyway, this is a picture that one of my students made of me, and it shows the work that I'm doing in the vertical curriculum. So I teach in the middle school, as Nair said, but I also have some lessons from the kindergarten through the primary school, the middle school, and also I have been teaching for a few years at university to special education teacher. I use educational robotics inside the curriculum, and since 2009. And I found really a lot of benefits in terms of competencies of my students. What is strange, and I wanted to tell you at the beginning, is in my classes I have a lot of students with a lot of learning difficulties because they, through the years, they selected themselves that working with technology is make them easier to understand mathematics and to approach to such kind of things. So we start with something interactive. Maybe you are used to that, and it's just to see what is your idea and what is the I want you to answer a question. So go to menti.com using that code, and just write down. I know that in the MOOC there is a section, but I want you to say what is the influence of mistakes in your students' approach to mathematics. I will share my screen if I can. Okay, let's see. Okay, so we will see together the results of the votes. So please try to go on Mentimeter and just type that code. I don't see anyone.
I'm there, but I'm
working there.
Screen, but I'm not sure.
0 people. So yeah. So you have you can do it with your phone or also with a computer. Go to www.menti.com and you will be asked to put a code. Then you find.
Yes, and then I can see but there is no question, so you do the question.
Picture. Yeah, it was a work, but anyway, we can make it working. It seems that it is working. Okay, doesn't matter. We can go on. Maybe something on the Mentimeter website.
Yes, because so you go to menti.com and you type in this code that Julia, sorry, was yeah, I think it was 2967, right? Yeah.
Yeah. Yeah. The code. Okay. Maybe we can be back. I will check for it later. And it was just to see using a word salad. What is what does in the opinion of the participants? What is the importance of mistakes in mathematics? And it was something to start from, because I think that mistakes in mathematics, maybe you discussed a lot, but are a starting point. And usually mistakes are the things that make students becoming afraid of mathematics. In this picture, you can see some robots in the gym. We were trying to introduce robots in a dance, and I asked my students to program the robots moving just from one side to the opposite one in the gym. And what they discovered was that if the robot wasn't built very well, and it means that also if a tire was just a few millimeters out of its shape, the robot going on distance was starting to move from the straight line. And they said it's strange because the more far they go, the mistake it comes bigger, and it was something really nice to make them discovering. It came from them, and we could discuss about how a mistake can be multiplied in mathematics, and the role of mistakes in learning. So robots in this case helped us to go through. Robots are very good when you work with in a math class, but not only in that one, to engage students, to work in an inclusive class, so to involve all the students, also those with some learning difficulties. It combines technology with pedagogy, so it's not just something for fashion. It's very nice because they can help working in teams, developing a lot of competencies, finding solutions without feeling the fear or having a bad evaluation, because when you make a mistake with robots, you just have to start from the point that you arrived and try to understand what was causing that mistake. So robots can be really very helpful. Of course, there are some learning mediators, because you can, if the robot fails, it seems that it's not the student who is failing, but they can help also them to discover through programming and through the results they can see what they, if the things that they were thinking about the problem were right or not. In this case, there are some students from the second grade, and they were working with angles. That is something that usually you develop at least in the third grade. So working with robots can help teachers to start in a different way and to approach in a different way. So it's a kind of different, the knowledge comes from a collaborative work. It's something that you construct with students, and it's really a scientific method that you can put on the field, on the floor. So something that maybe many people knows, because is related with robotics in general. That is, you can use robotics to involve students in STEM to stimulate motivation, develop key competencies, reduce gender gap, because through robots also, as robots are related with games, students are more eager to try, and girls usually are afraid, even if they are very good in studying. Sometimes they think they are not good enough for mathematics. If they fail, they think it's something that they cannot go over. But working with robots, I observed that they become more confident. Also, you can work with other schools even from abroad. So you start from mathematics, science, STEM subjects, but you go really farther from that. The kind of robot, the robotic kits is not important. So it depends on what you have in the class. You can work with simple kits, but robots are much more, how can I say, effective than just using software. For instance, I use also some kind of learning software like GeoGebra, but also Scratch programming or code.org that are marvelous. But if you add also some hardware like the robotics kits, you can prove what you tried to explore. As I was telling you before, in each class you have a lot of different students with different learning needs. So working with robots, you can approach all of them. It's a kind of going one-to-one, a kind of one-to-one learning, but also developing teamwork and going over their difficulties. Of course, technology is just one part. I think that technology is not the matter, but technology is just something that can empower the teaching, and it has to be joined with the pedagogy, with the contents. Sometimes you need to explain in advance, but it's just a few times. Usually you work with the scenarios, and sorry, I'm looking to the chat. If I okay, asking question. No. I thought it was something that I had to see. Yeah, of course, when you work with the robots, you have also to change the space In Italy, we are running a lot of improvement with the Piano Nazionale Scuola Digitale. We are opening some not future classroom labs, but digital classes. But also, if you are working in your normal class, you can change the space, work on the floor, try to set some corners in the class, good to present, interact. And when you work with the robots, you have all the phases that you can find also in the future classroom lab. So, it's good because after the first trials, it's normal for students finding some places in which store robots, in which go in with a computer to programming, others to show their work. And so it's not necessary having a lot of materials, a lot of technology. You can start really from scratch from your class.
You're not sure. I'm not sure if this is on purpose or it's just by accident. Just to let you know, in case you want to share it. Okay, perfect. Thanks. Now we can see it. Great. Thanks.
Oh, sorry. Okay. Something happened. Sorry. Okay. Sorry. I was in this picture. You can see some girls who are working on Mars. I was telling you before that it's important working with the scenarios. So you can teach a lot of contents, but it's better to put them inside a story or a scenario, because it makes things more funny, and it's easier to involve all the students in and taking active part to the exploration. And of course, you need to make different things according to the age, and also different kind of robotics kits. In this case, you can see there are some students from the kindergarten, and they were working on the line numbers, and they were for them it was easier, even if they didn't approach it before. It was easier making sums and subtractions, just observing the robots moving on the lines. The same things, anyway, you can use in the middle school, for instance, in the 8th grade, when you are speaking about relative numbers, because you can show that moving on the Cartesian axis can be shown with the movement of the robot. Sometimes, of course, there is not a proper syllabus to use robotics, so the teacher has to be creative. In this case, I was using Cubetto. Cubetto is a robotic kit for the kindergarten. I was using Cubetto to explain equations, and students had to discover which one was the unknown, observing the robot moving on the floor. So if you have some robotics kit, you can use all over and through the curriculum. The first activities that you can do is collecting data. So in this case, I asked some students to tell me the circumference of the wheel, and the wheel is not reachable, so they had to make some derivate measures. Each group, they were working in group. Each group had to propose their solution, and they were discussing which one was the best solution. Then we could try with the robot what was the right answer. Of course, your students are so happy of working with robots. They can also bring their own robot, like their own device. This one was a sphere, and it was one student brought at home, brought at school, and we were discussing that it was very difficult to measure the distance because a sphere has just one point in which it lays. So they weren't good in taking the measure. So we were discussing also on the precision of the measure. This is something really powerful. I don't know if someone else had the same experience I had. Working with geometry and with angles, when you arrive to explain the sum of the inner angles of a polygon, students have some difficulties in understanding how many degrees has to move the robot to make a complete turn. And they discovered that they hadn't to calculate the inner angle, but the external one. So first they draw the path, then they had to program the robot to make the turn. So they discovered that each time the robot has to turn for 360 degrees, but even if the inner angles had another sum. After a few trials, they discovered that it was possible to make only a single program to make the robot drawing all kind of polygons. So in the 7th grade, we introduced the functions. Usually functions in Italy is something that you introduce at the end of the 7th grade and the beginning of the 8th grade, so 13 years old. The robots that I show you are not really expensive, and anyway, this is something that we can discuss later. There is always a way to have some of them in the school. For instance, networking with other school, or just if you have one, you can work with one. If you have more, you can make students work in teams. So coming back to what I was telling you, in this program that is very easy because it's a visual program, it's a block programming, it's based on Blockly. They found the solution to make the robot, the Inobot was in that case, describing all the kind of polygons. Something very nice was done with this kit. This is a little bit. Little bit is linked with microelectronics, but it's very easy to be used because it has some magnets, and it can be used also from the primary school. If you have at school, you can work with the tinkering, so just build some things, but you can also involve in some math lessons. In this case, I put an Arduino board, you see the orange one, and I programmed the board to make like it would be 2 dices. So you see on the upper part of the picture, dado 1, dado 2, that means dice 1, dice 2. And in the inner part, you see sum. So 6 and 2 make 8. Each few seconds, the program changed the numbers, and we could collect all this data through an Excel sheet in which we could observe that if you have just a few data, you are not able to draw the Gauss curve, and on the left of the picture you see in yellow the numbers that are collected by the program each time that the dices are thrown, the digital dices are thrown. So we discussed and we discovered that we needed a lot of thrown before having the right curve. After showing the data, we had to record them each time that we work with robots. So we don't just play on the floor, but we also set the activities starting from observation, hypothesis, writing down the measures, then recording the data, and after that giving the solution. In this case, something very easy to do, but very powerful. We were speaking about temperature, and this was made, it was quite hot last summer, 34 degrees Celsius, and in the inner part, the same is in Fahrenheit. So the conversion could be made with an Excel sheet, but is just for elder students, or using the robots, in this case just some electronic kits, can be shown also to young students, and they can find themselves the relations and the ratio to go from Celsius to Fahrenheit scales. Something else can be done combining physics or science with mathematics. I often use to combine both of them because I think that mathematics can be powerful for science, and the same for many other subjects. In this case, I asked the students to program a robot moving for 1 meter with constant speed, and they had to try to different power. The robots can be programmed just changing the power in percentages, so they don't need to know at the beginning nothing about ratios and the way of calculating speed. But they could observe the effect of what they did observing the robots arriving at different distances one from the other. The program is something like this. This is the EV3, the Lego Mindstorm EV3 program. It's really easy to be used because it's a block programming. This program doesn't refer to the previous picture because this one is something related with a robot which moves following a line. If you use Scratch programming, you can ask students to calculate the common multiple. But if you add also Lego We Do, that is a robotic kit, you can observe the gears moving in reality, and this is more powerful because they can change the dimension of the speed using different the dimension of the gears using different gears, and seeing the effect immediately, and it's really more powerful. I leave also the link so you can use the same things that we did and try with your students. This is not one of my projects, but I used that because working with Scratch, you can find a lot of resources, and the same working with the robotics is very important sharing with the others, because this is the way in which you can be more confident in trying to introduce in the teaching, and also you will work less because you can share with someone else. This is another example of using Scratch programming. it was made in the 6th grade. We were starting speaking about the Cartesian plane and the Cartesian axis. So students had to move with the arrows, the little bit on the screen, and they found really impressive when they added some kit. In this case, we used the Make, that is a kind of little board, and I asked them to create a game and a joystick for the game. So mathematics comes linked to the reality, to the real world, and for students it is more powerful and more fun. Something similar in the Cartesian plan was made in the 1st grade. This is an activity that we made with the blue bot, that is the little bee, robotic bee. There is also an app that you can use also without the robot, but it doesn't the same power. Of course, sometimes it happens that you need to introduce concepts that are more difficult than the things that you are used to use in that class. But it comes easy for students if they can experience on robots, also going far away with the contents. The example here, we were working with the ratios in the 5th grade, so students that were just 10 years old, but they discovered the solution. If you have some kind of robots like in the picture, this is now a robot, you can also work with the 3 dimensions, but of course this is something that is not easy to have in the class because it's quite expensive, but if you have the chance to try, it's easier for students than for teachers at the beginning, because they can relate the things that they observe with games. Of course, if you work with robots, it comes normal and easy asking students to use robots to modelize and to build prototypes. In this case, I was trying to involve students with geometry. And we observed, I asked them which is the stronger structure in terms of geometry. We observed in the real world I don't know the English word. The crane I think is the name, and we reproduced with some strobies and some connectors. And we could observe that they can support also a lot of weight. In this case, I asked to build the model of some of the polygons with their diagonals, and they discovered that it's not easy as it seems, because if they are not precise, the diagonals don't meet at the center of the shape. If they observe something in the real world, you can ask to reproduce with robots. Like here, this is a grass cutter, and we tried to program robots moving like the grass cutter inside the perimeter, and they had to find the solution. We observed also that it's not easy doing whatever you want, because some shapes are difficult to reproduce, like the curves, the double curves, like here. And to succeed in this, we observed that you can do it with robots going with the logic. This program shows that you see that there is a double check. the robots move towards the black line, stopping one motor. And if the sensor sees reach the black, it goes away from the black, and so going with the logic, you can tell the robot, if something happens, then do this, else do something else. So you mix mathematics also with logic. That usually is something that you don't have time to explore in the class. Something else was done asking students to make a robot climbing a slope. In this case, the robot had to go over the slope, and they had to find the solution. I didn't explain them in advance the physics to do it, but they discovered by themselves that if they put some weight over the robot, it could reach the top of the slope. So it's something that the knowledge is constructed step by step, trying and discussing with the peers in the team. Also going with the Fibonacci series, we observed it's really linked with geometry, with mathematics, with the real world, and we tried and we succeeded to program a robot moving in following the Fibonacci series, and they had to find the solution, and it's not really easy. But when they succeed, they explore more than just explaining them something related with numbers. So they connect with the real, with experience and with the competencies. In this case, students built a guitar, and we were speaking about fractions. So the sound of the guitar was changing according with the wall of bricks moving on the pole, and according with the distance, it had to produce a different thing. We explained fractions, explaining the distance, the variation in distance. So I spoke a lot. I'm not. Maybe I didn't tell you all the things that you can do, but I tried to give you some ideas on the things that you can do with the robots.
Yeah, you've been clear, you've been great.
Now is the time for questions.
So thank you very much. You have provided us with many tools and resources, and I'm sure the teachers will find this useful in order to implement those in their classroom as well. So yes, so we have one question so far from Anika, and she was wondering if you just teach math, and how many lessons do you have per week, and when do you teach coding as well?
I teach math and science because in Italy we have math and science, and we have 6 hours per week. I teach, I use robotics inside my teaching. So some of the lessons, at least 1 or 2 lessons, are done with robots. Some colleagues are worried about the contents. They think that there is not enough time to make everything, but there is a different approach. Each time that we program a robot or we make a robot moving for 1 meter, we can discuss about the circumference, we can discuss about measuring, we can discuss about the solutions of a problem. It's a different way of organizing the time. Of course, if you have some colleagues of technology that can help you in explaining how to program a robot, you can take advantages. But I can do all the things, and the success in terms of benchmark of my students is greater than some different students in other classes, even if I have a lot of students with learning difficulties. So
it's true. It's true that we have sometimes teachers saying that how is it possible to cover the whole curriculum while introducing at the same time robotics? But then it's true, you can make it. It's not a lie, right?
Yeah, in many countries, usually robotics is done outside of the curriculum. But I think that is a different approach. You can, of course, do it out of the curriculum to take part to fairs, but it comes that you have the best students that are already interested in doing it. If you use in the class, you have all kind of students, and it comes like really a learning mediator, and you can approach to all the students. The teacher hasn't to be very proficient in this. My degree is in forestry sciences. I'm not an engineer, but I discovered that if you know well your program, your content, what you want to teach, students can help you with the technology. So also the role of teacher changes. You become more a coach than just a teacher. Of course, you don't stay behind the desk, and you need to work with your students without giving suggestions, but just discussing with them which could be the best solution. And I find a lot of satisfaction. Last June, I took part to a training course for teachers on Minecraft. Also, Minecraft is, as you discussed inside the MOOC, is very powerful. And what I discovered is that when I came back in the class after the training course, I was enthusiastic about the Minecraft, but I didn't have a lot of experience in working with my students with that. But I told my students, and they said, okay, if you tell us what you wanted to teach us, we can explain you how to use some tricks on Minecraft, how to, so we learn together. And really,
sometimes teachers also feel a bit afraid, let's say, because they think that students know a bit more than them, but this is also something that you could take advantage of, like you just mentioned right now.
I think that one of the problems for teachers is the fear to be judged and not to be good enough to control the class, but it's not this way. Of course, you don't have a lot of soldiers, like silent students sitting in their place, because of course you need to work and to stay on the ground, to discuss. But really, in terms of competencies they develop,
and we have a question from Teresa, and she's asking if you organize a lesson in project outside the typical lesson. I'm not sure I understand the question either. So, Teresa, can you maybe rephrase your question? So, do you organize lesson in the project outside the typical lesson 6th for a week? In Italy, let's see, because I'm not sure. Teresa, if you want to talk also, you just let me know, and I'll give you.
Lesson project outside the typical lessons. Yes, I understood maybe what she was. Yes, we work also in scenarios. Sometimes now we were working about the universe, for instance, So the projects are inside my school with my colleagues, or also outside. I don't discuss about projects with other schools, so we are involved in some Erasmus courses. We set our atelier and we have extra hours on Saturday. Last Saturday we started with 3D printing with the students, and we had students from the 2nd grade to the 8th grade, more than 50 students, and it was extra hours. But I think that what if she makes the lesson during the 6 hours a week. Yes, but I extend something. I needed to extend the time using some learning platform, like we use Google Drive and the Google Classroom. So I ask students to send their solutions or send their works on the cloud, and so we have to extend sometime the hours. But usually in my 6 hour time,
Great,
I can
thank
do
you.
all the things that.
Okay, so I don't know if you have any other question for Tulia. If so, please write them on the chat. And in the meantime, I'm going to take advantage of this time also to let you know that since we have been learning about so many tools and resources that Tuli has just mentioned with robots and software and hardware, just to let you know that this Friday we are running a hackathon here in European Schoolnet with the Future Classroom Lab ambassadors as well. So maybe this is also a good opportunity for any school if you want to participate with your students. So it will be like a 8-hour competition, and you just need.
If you can, I suggest you to take part. Last year we took part with my students, and it was really terrible because they and it's true. It's good to understand for students. It was a great lesson. Because they were enthusiastic. They were from the 7th grade. They took part to the hackathon. They needed to prototype things, but at the end of the day, what they produced was horrible. Nothing really a prototype. And they said, do you think that we can upload this material? And at home, they are always good students for their mama, for their teacher. We always give them prizes or a good evaluation if they do just a little. But if they compare with other students, they can observe that you need to try to do your better. So the hackathon is a really great
not only just to have a prize and final prize, but just to participate with your colleagues and students from other countries as well, that you're all together participating in a joint competition.
The only problem, there is a problem, at least in the school in Italy, that is that the hackathon lasts for 1 day. And you needed to organize in advance because last year we started at school and students went at home and they continued by themselves because we couldn't stay at school for the whole day. So it's something. Yeah. There is something that I wanted to tell. Someone asked about the price of robots. I think it's not about price. When we started, I started working with robotics because of one of my students with the special needs, and we took part to a workshop, and I became enthusiastic. And we just had one robot. They borrowed us one robot, and for 1 year we worked with just one robot, and it was powerful. When we had the chance to buy another one, we worked for another 6 months with just 2 robots. So you can buy little things, add more and more, or take part to projects. Or one good idea is to stay in network with other schools, and you can borrow each other the robots. It's just about planning how to use them. But indeed, they are less expensive than many other things that you use at school, and they last for a long time. And it doesn't matter. Of course, there are cheaper materials like Arduino board, but you cannot use with younger students in the early ages. It's better to work with that. I prefer to, yeah, I prefer to work on mathematics than on robotics. So robotics for me is just
it's good that you mentioned that it's a good idea to share the robots with other schools, because this is something that we hear a lot, that we cannot afford to buy this robot, for instance, the EB3, the Mindstorm, which are quite expensive, but it's sharing at the end. It's also, of course, a very good idea.
Yeah, I see a question about which kind of robot are good to start in a math class. It depends on the age. If you are, it depends if you are in the primary school, in the middle school, or if you are in the high school. In the really early age, I think that Cubetto and Bluebot are very good, also Innobot. 11 to 14, that is the age of my students. I think that if you have to choose, Lego Mindstorm and Lego WeDo are great. Also, even if it's not very known, Innobot, that is the one that I show in one of the picture. Let's go to Innobot. Innobot is great in the class. This one. Innobot is like the Bluebot, but you can program it really deeply to work with mathematics. Of course, if you work only with mathematics, it's quite boring. You need to take the chance to use robots also to make math lessons more fun, more engaging. So you don't need really to just teach mathematics like in this picture. It's much more better working with the scenario and developing the things that you can find with the robots. So for instance, if you just ask to make a robot working as a rescue robot, you speak about an earthquake. In Italy we had a lot of earthquake. You put some stuff in the class, so you can speak about orientation, and they have to follow a path, so you can give coordinates, you can ask them to measure the distance, you can work with the perimeter, you can work with the circumference of the wheels, you can work with logic, with the sensor. So in one lesson you can experience more concepts, and
So
you don't need really
things in just one
to
lesson.
make boring things. Yeah. And money? What
I
is
think I
money?
lost you for a couple of seconds at the end, so I'm not sure what you were saying. I think you were
Money?
saying that in one lesson you could touch different things. You could, and money. I think maybe she's referring to the money that the robot could cost.
Yeah, of course.
I don't know if Antonia, if you're still here. So Antonia, if you're still here,
In
is
Italy,
this your
we have a lot of opportunity nowadays. We missed your voice, Nair. Anyway, I think that
It's okay.
if we follow the opportunity, not only in Italy but all the country, also a lot of projects. We began working with robots because of some European projects we took part. Then we exchanged with other teachers from other countries that were more experienced. And starting from that, we tried to find our way and become more experienced on that. So European projects can help you in funding, or also you can pair with some Fab Lab or with some Coder Dojo. They are happy to help you and borrow the material. So it's not necessary to have a lot of money to run some robotics lessons to empower your math class. Okay. Let's see if
thank you very much, Tulia. I don't know if there are questions. If you have any other question for Tulia, grab them on the chat. Otherwise, her email address is there. So in case, I guess, if you have any question, you can also contact her. And we will share the recording in the course platform, the relevant section of the course, and also the presentation as well. Tulia, do you agree? Okay, and I think that because there are no more questions in the chat, so thank you very much, Tulia, again for this very nice and very especially inspiring webinar. We got many tools, resources, hardware, software that teachers can use. Now I just hope that they find the time and the strength to learn how to use them, and also to use them with their students, because at the end I think it's really worth it. So thank you very much, Tulia, again for a very nice presentation and very inspiring. And just a quick reminder for the audience as well.
And if you have here is my email.
Yes, so the sound is coming a bit late, but I will just say, Tulia, if you allow me, that I will just remind the participants that don't forget to submit your learning activities so that you can get the course badge and the certificate. And if you have any question, let us know. And stay tuned to social media channels, Facebook group, Twitter with #Mac2MOOC. And just to finalize, Tulia, I'll give you the last word. So thank you very much again, and I hope to see you soon.
Thank you very much to all, and sorry for my English today. I was very tired, so it was not so fluent like I wanted it was.
Okay, thank you, Tulia.
So, bye-bye.
Thanks again, and have a nice evening, everybody.